Welcome to Lights Out. I'm John Weiss.
And I'm Andy Henderson. And today we're talking with Laine Mears. He's the professor and BMW Smart State Chair of Automotive Manufacturing at the Clemson University Department of Automotive Engineering. And Laine and I have known each other and worked together quite a lot over the years. So I'm really excited for this conversation on a ballpark percentage basis. What do you think the percentage is of students who conduct research for a company that actually go into that company? I know that was my case. The research I did during grad school was for the company that I ultimately went to work for a few years, for a while.
Well, in our program, automotive engineering at Clemson, I would say 100% of the students that do research in the areas that we're interested in go and work in that area of interest. So they may not work directly for the company that we're talking about, but they go work in that area of specialization within manufacturing. So they'll go to automotive companies if they were doing vehicle design, such as this one I've got behind me now. So this was a project with Honda to develop a race car that's an electric hybrid race car. And now we got a ton of students that go up to Honda and work with them. All the students in my research group that deal with machining, joining, forming, and assembly processes will end up in a company that does those things.
So that to summarize that, what I think I heard was, the students may not go directly into the company that they're doing research with, but they are definitely going into the industry in the field that they specialize.
But no, not to say that doesn't happen. We've got students that do that. We have a big joining project that we've been working on with a couple of companies, and we have students that just jump right into the companies after they're done. So that, we hope that continues. But that's just a little trickle of talent. Right. We got to be thinking in bigger terms. And
yeah, no, for sure. And I know it's still bigger term, but one of the other things that would be interesting for some people, I guess, would be like, larger companies tend to have their big recruiting events. They have their list of schools that they like to go recruit at, and they go to the fall and spring recruiting sessions, and that's where a lot of the new hires come in from. But for a grad student, you can attend those things, but I know my own personal experience from grad school was that a lot of it came from word of mouth and from relationships and networking. I don't know. What are your thoughts?
It took me far too long in my life to realize the importance of building relationships and within your professional community. That's the only way things happen. I do remember reading the Nelson Bowles, What Color Is Your Parachute book, and was really struck. The only thing I really took away from it was, besides finding a career of what I can do, what people will pay me to do, and what I love to do, if you could find the intersection of all those things, and that's the magic. But the other thing is the way people go looking for jobs, is typically go look for want ads in the newspaper or monster.com, go to career fairs, then go cold call companies, and then start dealing. And then I'm down in the dregs, and I got to start dealing with the relationships of, you know anybody, And the way that companies look for people is they ask their employees, do you know anyone that fits this? And then they look for, who's taken enough initiative at least to call them. And then they go, I guess we got to go to the job fair. And they're, we can't fill the job. Let's go post a want ad. It's exactly opposite of the way that people are taught to look for jobs. But what I do for students, and what we try and do within our program, is if you're going to go look for a job, no matter what your technique is, you and everybody else in the 95th percentile, is lining up to look for the same job. And there's a lot of talent out there for the jobs that you really, really want, and the companies that are really, really desirable, the cultures that you're looking for. And so we try and give them everything that we can to move them from 95 to 97 to 98 to 98 and a half. What are those little differentiators in terms of the experiences that you've had, the way that you can present yourself, and the things that you can do, like the car that you see behind me. We got students that can go into a job interview and say, I worked with a team to design and build a vehicle from the ground up, just like a product development process that people take years and years to understand within your company, walking in cold. And then they pull out their portfolio. And, yeah, here's me working on the powertrain. Here's my team working on the body structure. Here's the analysis that we did, and just like the complete package. How do you argue with that, right? That's in
that's
my mind.
powerful.
That's immediately, you're our guy or you're a girl, sign here.
So,
And so that's what we try and do and those little differentiators make a big difference. My students get annoyed at me when I come back on their papers and say, you forgot a semicolon here. Would you cut it out, Mears? What's you're so detailed. Yeah, that's what makes the difference, right? That's the things that people will notice, and that semicolon might be the one thing that sets you apart from the next person down on the list.
so one of my questions for you, Laine, and I think you just answered it. The question was going to be, how are universities, specifically programs like yours, preparing the next wave of manufacturing employees? And I think you just really answered that. But if I could boil it down and maybe summarize it, what I got out of that was, you're bringing a lot of real world type projects to them in the academic environment, so that when it's time to hit the job market, when it's time to find a role, and most importantly, when it's time to bring value to a manufacturer, they can point to a list of things that they've done that relates to real world type needs and projects. Is that fair?
Yeah, I wouldn't say boil it down, John. I'd say boil it over, because there's a lot there, in terms of creating an experience for students where they can go be valuable to a company from the very beginning. So our program in automotive engineering is built on systems integration, which basically means that you work in a field, in an area, but your area touches lots of other areas, and the decisions that you make in a mechanical system, for instance, are going to affect the IT systems and the electric systems and the noise and vibration systems, and everything else that you got to know about the car. Similarly, the design decisions that you make have a great impact in manufacturing, and vice versa. So I can work in manufacturing, and I can push that back upstream to the designers and say, hey, we have new capabilities now. So building a program where you teach that integration of understanding in fields and technologies, was what we set out to do 15 years ago, when we were really putting the details of this thing together. And now you see that showing up a lot. Now you see that showing up in a lot of multidisciplinary education programs. Now the new concept is convergent education programs, which goes beyond multidisciplinary. So now it's not just disciplines exchanging information, but now it's disciplines crossing over and working in each other's fields. So we're starting to do that a lot more with our research, and we're looking for, I talk about the future of manufacturing. The future of manufacturing is convergent. It is not just mechanical systems, it's not just control systems, but now you're seeing this big influx and interest in artificial intelligence. That's computer science. And then our work is in how all of those new technologies are affecting people in manufacturing. And you'll see a couple examples in the literature of companies that said, robots, let's go, get rid of all the people. We're putting robots in, we're automating everything. And then 6 months to a year later, pull all the robots out. That was a really bad idea because robots don't work the same as humans do. And we thought that was a good thing, but now we realize that there's a balance there that you have to strike. So you've got people and technology working together. And so it's really important to understand that, not just from a technical standpoint, and not just from a computer science standpoint, like the way a artificial brain thinks. You have to understand the way a human brain thinks. So we've got psychologists on the team now that are working on what stresses people, what threats people have, and where people get their enjoyment and their fulfillment from their job, and how do we take those concepts and feed those back into the design of new manufacturing systems. So how can you make a manufacturing system where somebody gets up every morning, ready to go to work and excited to go to work, and really looking forward to that? That's somewhat alien of a concept. Yeah, it is when you're going in every day, screwing the screw into the bracket for 8 hours. But it could be more exciting if you're going in every day, maybe talking with your machine and exchanging information with your machine and learning from your machine and teaching your machine and having a more engaging type of experience with the system.
I think I'm about to put you on the spot, but I was wondering, is there any particular research in that area that you would cite as being, that has come out in the last year or two, that would be, really that had some result or some finding that was truly novel and interesting?
Yeah, I mean, there are some spotty results, and I think they're motivating a lot of new looking at the problem. So collaborative robotics is a great example. People and robots, and now these new robot designs from new companies like Universal Robots, and you see new designs coming out now from Bosch and KUKA and some of the more traditional companies also, where they have a robot that has some additional sensing built into it. So if it turns around and bumps into a human, it stops and it won't it won't cause physical harm. But people really haven't realized the potential of that yet. You'll see a few applications where the robot's picking up the material and showing it to the human, and the human's doing their work on it, and then the robot's adjusting it, and the human's doing work on it, or the human's doing work and the robot's sort of leaning over their head, inspecting and bringing them tools and flashing up information that they need. That's a real sort of collaborative team type of environment, but those are few and far between. You see a lot more of, oh, robots and humans working together. Great. So when we have these two people doing operations on the line, let's just pull one of those people out and put a robot in. And that's okay now. We couldn't do that before because we didn't have the floor space for the cage. But now we don't need a cage, so they can work close together. But there's no sort of interaction. It's still 1 + 1 = 2. And there's a lot of potential there for like 1 + 1 = much more than 2. If they're working together. And that's just for robotics. So that's physical types of systems. Now you're seeing some evolution of what I consider a misnomer, artificial intelligence, which is really artificial agents looking at data and finding patterns that a human can't necessarily divine from the data, and being able to classify things and being able to feed back information about this is good, this is bad, this is questionable. And so you have a better integration of artificial agents doing what they do well, and humans using that information to make decisions. So those kinds of things are good, and it's good that we're moving in that direction because it's making manufacturing faster, more productive, and making quality better.
So,
But if you look at real artificial intelligence, that's just getting started, really, in systems that can think for themselves, that can make decisions for themselves. Those kinds of things are really just sort of crawling out of the primordial ooze right now in labs around the world.
yeah, doesn't that make sense though? That that up until now, it's been a lot of pattern recognition and classification of things, and it's just now that we're starting to get into because I think as humans, I feel like as humans, that's what we do, right? We do a lot of our own pattern recognition and putting and saying, when this happens, that always tends to happen as well. And that's a key part of how we learn, how we start to, and it's probably later after we've done a lot of that pattern recognition in our younger years that we can start to say, well, what if instead of just letting that thing happen and that thing follow, what if I somehow modified this in such a way that I think that's going to, is that kind of is that the type of thing that you're getting at when you say that the AI agents are starting to actually think for themselves? Is that what you mean?
Yeah, I mean, in my mind, it's the difference between learning and gaining wisdom. So when you learn, it's like a child. You observe phenomena, you compare that to what your belief system is in your head. If it doesn't match, it sort of forces you to modify your belief system, and then that's learning, and that's how your brain changes. Um, but as you get older or have more experience in that, you start to realize maybe some more implicit relationships, and you start to put pieces together from very far away and understand that those are the same things. There's the book, Gladwell's book Blink, that sort of talks about, you glance at something and you just kind of know, right? It's this gut instinct, and there's some real science behind why that happens. And so we researchers I'm not an artificial intelligence person, but researchers are starting to train systems to be like that. Not such explicit, this is broccoli, this is broccoli, this is broccoli, and so find all the broccoli, but more, um, yeah, finding these really higher order relationships, and combinations of different kinds of data streams. People are thinking they're getting really fancy when they're combining vibration and sound data together, but there's just so many different sensing modalities out there. I don't think that and I think that, we say humans have five senses. I think there are some sources that say 12, there are some sources that say 38, different types of sensing that humans can do, and animals have multiple senses that humans don't have, heat sensing and magnetic sensing and those types of things. What happens when you make all of that information uh, uh, translatable in a way that you're not overwhelmed with just the bandwidth to communicate all of that, but then have agents that can kind of be adaptive to lots of different streams and start to find patterns, and even what you're saying is decision making. If I start to change one of the inputs to affect a change in the output, I can start doing some really cool stuff. And if I can do that artificially, I can do that much more efficiently. I can do it with a lot more confidence, or at least understand the confidence. A lot of times with humans, it's, yeah, let's try it and see what happens. Artificial agent is going to be able to say, yeah, I can do that, and I'm 88% confident that it's going to have this type of effect that's going to benefit, whoever is going to be the beneficiary of that. that
Absolutely.
that brings up the types of studies that are going on now, is understanding, oh, wait a second, now you're not just putting a robot in that's threatening somebody's, the bracket screwing guy or girl. Now you're putting in systems that's threatening the middle management and the operations managers and the production schedulers, and all these people that formerly were, oh yeah, I'm not afraid of robots, but I could be concerned about artificial intelligence agents. And we need to start thinking about those things now, because that could have a really big effect really quickly. It could be like the electric cars of the manufacturing floor, right? We see electric cars are coming on a lot stronger and a lot more rapidly, and autonomous driving cars coming on a lot stronger, a lot more rapidly than anyone ever thought possible before.
How does academia keep up with it? So what's happening, inside the walls of a university in programs like yours, Laine, that are prepping the next wave of folks to actually embrace this kind of technology?
Yeah, we're pushing a lot in these areas, in terms of designing projects for learning. So we have a program that's called Thinker. It's technology, human integrated knowledge, education, and research. So how technology and humans work together in a manufacturing environment. So we design projects that purposefully push the students into kind of failure opportunities for learning. So trying to put people and technologies together in ways that don't necessarily work well, and then sort of guide them and use that as a learning opportunity to guide on how to make that a good outcome. We're doing research that's a lot more convergent now. So we're starting a new project with psychology department and with IBM Artificial Intelligence Group. And this is under a new NSF program called Future Manufacturing, where they said, what's manufacturing going to look like 10, 20 years down the road? And what do we need to start investigating now in order to see what that looks like? And so it's me, a psychology professor, and an artificial intelligence organization sort of all getting together and looking at human teaming models, which to my surprise are not fully fleshed out. We still don't know a lot about how humans and humans work together, but trying to apply what we do know to how humans and artificial intelligence agents are going to work together in the future.
When you say we don't know how humans and humans work together, you mean, is that to say that there hasn't been a ton of published research in that area?
No, there has been a ton of published research, but humans are extraordinarily complex, and I think there's still a lot to be worked out. Thinker really became initiated from an idea that we have Industry 4.0, we have data streams, we have sensors, we have automated systems, we have automated software, we have decision making that's happening, but we don't have people anywhere in that other than standing at the periphery and maybe looking at dashboards or maybe making some high level decisions. So Thinker came about when we said, how do we get people like integrated into that system? How do we make, we call it instead of an Internet of Things, an Internet of People and Things. So how do we get people integrated into that Internet as well? So we're looking for technologies such as like wearable systems, where I have wearable sensing systems where the human can provide data to the network, and feedback technologies. So you mentioned, like augmented reality. That's a cool idea. It hasn't caught on as big in manufacturing as you might expect. There's some resistance to, I don't need to be wearing this big, Darth Vader headset all day long. So what are some technologies and some modes of feedback of information, and how does that change person to person? Like, can a person walk up to a station and say, I like to see visual things in 3D, and somebody else says, oh, I like to hear instructions read to me. Can we adapt technologies and stations for the individual people that are using them? Those are the kinds of things that and I feel like we're just getting started. I think that those are just sort of the low-hanging fruit kind of stuff in this new domain, but I think there's a lot more to be done there.
Andy and I have talked a lot about this really being the land of so what, right? Every time you talk
Yeah,
about
right.
industrial IoT, Industry 4.0, most of the dialogue, it's around answering, so what? Why do I want this? What's going to happen if I adopt some of these technologies? And if you walk into 5 different factories, you're going to get 7 different answers on why people want this stuff. So
that's right.
I think you summed it up really well. There is
if you're like, I'm trying to put a man on the moon, any questions? That'll be, oh, gotcha. Right. I understand that.
I don't want to sound like a downer on it, but is it kind of the plight of manufacturing to be that? Because like Henry Ford said, I want to make cars that my employees can buy. And so therefore he revolutionized manufacturing. Right. It was the manufacturing was again the means to that end that he had.
Right.
I'm oversimplifying that greatly, but
no, that's a good way to put it, and that was a great vision for the time. That was 1916, right? It was over 100 years ago that he's saying, I have a vision, and there's no way to do that today, and so we're going to change the way that things are done. What's the next vision? I guess that's our job, right? To come up with what that should be.
But yeah, that's exactly right. I think my point was that the reason you walk into 5 factories and get 7 different answers is because everybody has their different opinion about what they're trying to solve, and they're going to use manufacturing and manufacturing technology as a means to achieve whatever their personal end is.
Yeah.
and a lot of the companies are, their objectives is to um, increase is to improve is to is to increase returns to shareholders, right? And you want a way of doing that. One of the knobs you turn to do that is increasing productivity and making more things you can sell at a lower cost and lower number of inputs. And so manufacturing has a direct play to help to that end.
Oh yeah, no, the potential is really there. I think we just need sort of a rallying cry to get behind. So you can answer that, because that's a lot of companies are like, smart manufacturing. Yeah, smart me up. I love that idea, but what do I do, and why am I doing it? What am I going to get from it? And
Yep.
that's I think that's a good thing to be thinking about right now. So we got some low hanging fruit that we can pick and use this industry 4.0 stuff, to get walking before we start flying. I think people are looking for the fly solutions, and there's a lot of walking that we got to do.